So we have till now we have completed the Codelab up to this point. The state driven way. Let's learn about remember. So in this Codelab we have used this remember block which preserve the state, which preserve the previous state of this observable mutable state. Okay, so remember storing object in composition and forget the object if it's the source of location. How to remember is called and not it is not invoked again in decomposition. So remember stores object in the composition and forgets the object if the source location here remember is not invoked again during a recomposition. To visualize this behavior, you will implement the following piece of functionality in the app. So to visualize the behavior, you will implement the following piece of functionality in the app. When the user had at least one glass of water. So when the user has had at least one glass of water, wellness display a wellness task for the user to do, uh, that they can also also close and they can also close because composable should be small and reusable. Create a new composable called wellness task item that's so to visualize a behavior you will implement the following piece of functionality in the app where the user had at least one glass of water. Display a wellness task for the user to do so that they can also close because composable should be small and reusable. Create a new composable called wellness task item that display the wellness task based on the string received as a parameter along with the close icon button. Create a new file wellness task item and add the following code. You will use this composable function later in the Codelab. Wellness task item. So item is this, this kind of thing. Items. Text checked, unchecked, and then close icon. This close icon. So it's in a row. It's in a row. It's a one row. So that's the item we are creating. Let's give it a compose wellness task item. We have created an event on close anonymous function. Let's learn about what this is doing. We will not go how the UI is structured because UI part is done in the previous Codelab. Let's import those. So wellness task item on close. So the wellness task item function receives a task description, text and icon button. Okay, so text and icon button. Close. It's not still unchecked. Unchecked is not still in the item. We'll add this after. The wellness task function receives a task description and the onClose lambda function. So the wellness task function receives a task description, receives a wellness task, receives a task description, and the onClose lambda function just like the built-in button compose receives on, just like the built-in button compose receives an on click. Wellness task item looks like this. Wellness task item looks like this. So to improve our app with more feature, update the water count to show wellness task item. To improve our app with more feature, update the water counter to show the wellness task item when counter is greater than equal to 0. When the counter is greater than equal to 0, show task. Okay, show task. What does it mean? If mutable state is a boolean state, taken your 15 minutes walk today? Have you taken your 15-minute walk today? Okay. Let's see. Count greater than equal to 0. If count greater than equal to 0, we have added a mutable state of boolean short task. If it's true, which is true, with greater than equal to 1, this compose function will reflect in our UI. To pass this dot on close ticket icon button. Tasking, have you taken 15 minutes walk today? Let's run this application and see what the app has to say. Have you taken your 15-minute walk today? It's coming on top. Add one. So next, add a new button with a text clear water count and place it beside the add one button. A row can help align the two buttons. You can also add some padding to the row. When the clear water count button is pressed, the variable count reset back to 0. If it is true, then wellness count will show. Have you taken 15-minute class? If it's greater than equal to 0. So this will now add a button next to clear water count. Text clear water count. What does it mean? You have had count of classes. row with the button add one. What we've done inside, so we have a water count returns to 0. Let's run this application. So there's a powerful concept how declarative UI is really helpful. So for example, let's add 4 classes, 5 classes, 6 classes. When we clear water count, it returns to 0, and then we don't have to set the count to 0 or something. It's automatically reflect the changes, and it starts from 0. So that's a very powerful concept. So when the app, for example, what I was telling is, so so after adding those button like this, after adding this clear water count in a row, what happens is the count variable returns to its count variable, the value of the count variable set to 0, and when it's set to 0, we don't need to explicitly uh, remove the visibility of this column, right? We don't have to visibility of this, I mean of this item that have you taken 15 minutes of this wellness item task or this text. Okay, it removes automatically because it's a declarative form of UI. So that's the whole point of saying. Let's run it again and I'll show you. Add 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and if we clear it, it automatically set to 0, and if it's 0, then this also get invisible because this also gets invisible because if it's not greater than 1, then nothing will display. Okay, this code block would not display, so nothing gets reflected in UI. So when you run the app, your skin shows the initial state, which is this add one skin and clear water count. Column count equal to 0, so add one button, clear item button. To the right, to the right, we have simplified version of component tree here, which will help you analyze what is happening as state changes. Count and show task are remembered value. So count is a remembered value and show task are remembered value. These are two states in this application. Okay, so there are two states in the application: count and show task. Okay, count and show task. Count and show task. So now your app follows this step in the app. Now you can follow this step in the application. Press the add one button. Now press the add one button there, that increment count. So this causes a decomposition. Press the add one button. Press the add one button. That increments count. That increments count. This causes a decomposition, and both wellness task item and counter text started to both wellness task item and the count wellness start item and the counter text start to display like this. Okay, press the X of wellness item component. This causes another recomposition. Press the X of wellness item component. This causes another recomposition. So task is now false, which means wellness task is not displaying anymore. So wait a second. Show task. We have not called this, that's why it's not working. On close equal to show task equal to false. So everyone, have you taken a 15 minutes walk today? And short task became false. Now false, which means wellness task is not displayed anymore. Now, because we have set the short task to false, wellness task is not displayed anymore. So press the add one button. Press the add one button shows us remembers we have closed wellness task item in the next recomposition if you keep adding classes. Short task is still false. We have added 2 classes, 10 classes. Clear item, add one. We have added 2 classes. So press add one button. Another recomposition short task remembers we have closed wellness task item in the next recomposition if you keep adding classes. Press the clear water button to reset the press the clear water button and reset the count to 0. Reset the count to 0. Reset the count to 0. Uh, and cause the recomposition text shows the count, all the code related to wellness item. Cause in the composition text shows showing count and all the code related to wellness task item and are not invoked in the leave composition. So the currently when you click on the clear water count button, then it becomes 0 and it's recomposition from this code block. Okay, recomposition from this code block counter if it's greater than 0. So the count is so because the count is greater than equal to 0 when you press this one, so this recomposition again, and then this code block again starts with a fresh true. So when I add one item, for example, when I press the add one item, and if now the count variable is, for let's say 8, okay, because count is now 8 is greater than equal to 0, and if we close this If we close the wellness task item, then we still add one other item which will then turn out to be 9. Count is now 9 because it's inside this count greater than equal to if block, greater than equal to 0 if block. So the show task remembers its previous state, which is false. So it won't show this wellness task item. Okay, but when we clear the water count again, turn out to be 0, then it goes again to 0, and then when we press click on the counter variable, then it start from this, and that remember block again start from a fresh recomposition. So that's it. So press on the clear water button, reset to 0, and causing the recomposition text and showing count and all the count 0 and cause a recomposition. Press on the clear water button, set the count to 0. So press by pressing on the clear water count button, reset to count to 0 and causes a recomposition because everything revolves from this count. Because everything that's happening on this composable function is related to count. So when count becomes 0, everything gets to fresh recomposition and resets to initial state. So pressing the clear water button, reset to count to 0 and causes recomposition text showing count and all the codes related to wellness item are not invoked and leaving composition and leave the composition. Count greater than equal to 0 button, clear amount button, currently equal to 0. Text shows false. Show show task is forgotten because the code location where remember show task is called was not invoked. You are back on the first step. Show task is forgotten because show task is forgotten. Show task is forgotten because the code location where the remember showcase is called was not invoked. You are back to the first step. Show task is forgotten because the code location where remember show task is forgotten because the code location where remember show task is not invoked. You are back to the first step. Press the add-on button making the count greater than equal to 0. The wellness composable displays again because the previous value of show task was forgotten when it left the composable above. So press the add-on button making count greater than 0. Wellness composable displays again because the previous value of show task was forgotten when it left the composable above. So if we require to show task to persist after count, so if we want if we require show task to persist after count goes back to 0 longer than what remember allows, this is even That is, even if the code location here remember is called is not invoked during decomposition, we'll explore how to fix this scenario and more example in the next section. So what if we require shortest to persist? Shortest to persist after count goes back to 0 longer than what remember allows. Okay, that is, even if the code location I remember is called is not invoked during decomposition. That is, even if the code location where remember is called is not invoked in decomposition, we'll explore how to fix this scenario. Okay, now you can understand, now that you understand how UI and state reset or leaving the reset when they leave the composition, clear your code and go back to the water counter you had in the beginning of this section. We will count classes. Now that you understand how the UI state reset when they leave the composition, clear the code and go back to the clear your code and go back to the water counter you had at the beginning of this section. Okay, now we understand what is recomposition, composition, mutable state, and remember this in a very in-depth way. Now he said to remove the clear your code and go to the back to the water counter. Let's remove the wellness task item and copy this composable and this water counter. Because we just understood the concept of state and remember in composable. Let's keep this code, man. Let's keep this code because for the reference. Okay, and then paste the other code and then now run this application. Add one, we have two. One thing I also want to say, okay, so whatever the parent mutable state is doing, for example, is this short and this short as remember will be based on if counter is greater than equal to 0. So parent, if the parent goes to its initial state, so this also goes back to its initial state if we don't preserve the state, preserve the remember. So there's also a concept. It is not mentioned in this Codelab, but I know that's this. I know that because this remember mutable state is based on this count mutable state. So if this gets back to its initial state, if this gets back to initial state of 0, then this will also uh, come to its initial state. Okay, so shortest is forgotten because the code location remember shortest was not inputable and back on the first step. Okay, now let's go to restore state in compose. I want to know one more thing. Wait a second. If I give remember saveable, does it also work out as we've expected? Let's see. Let's remove this water counter and run this application. Let's see the behavior. Okay. Now let's see. Remember save. Let's see if we give remember saveable to this, and let's see if this item preserved. No, this item is not preserved because still it's the parent is giving direction. Parent, it will be depending on parent classes. So if we even give the remember saveable, it doesn't work out as we expected. Okay, let's comment out this line. Let's uncomment this. Okay, now that run this application again. On the app, add some classes of water account and then rotate your device. Make sure you have device auto rotation setting on because activity is recreated after configuration changes. In this case, orientation, the state that was saved was forgotten. So if we rotate the device and the current state is forgotten, so how to preserve it? Basically, that's the purpose of this Codelab, restore state in compose. Basically, because activity is recreated after configuration changes, orientation state that was saved is forgotten, the counter disappears and goes back to 0. So the same happened if you change the language switch between dark light theme or any other configuration changes that makes Android screen recreate running activity. Okay, when configuration changes like that, converting between dark theme to light theme switches the language of the application on screen rotation. If we don't preserve this, then this will get back to its initial state, which is 0. Let's see. See. So while remember help you retain state across decomposition, it is not retained across configuration changes. While remember helps you retain state across decomposition, it not retained across configuration changes. For this, you must use the remember saveable instead of remember. Remember saveable automatically saves any value that can be saved in bundle. Bundle if you were coming from the Kotlin XML background, then Kotlin the previous way of saving any value is in bundle in screen orientation. So remember saveable does exactly the same under the hood, like, like we did in bundle in the Android XML code view-based layout. So for other value, you can pass it in the custom save object. So remember save automatically saves any value that can be saved in a bundle. For other value, you can pass it in a custom saver object. For more information on restoring state in compose, check out the documentation. You can check this documentation up about how to restore state in composition. Remember saveable. Okay. Parcelize. Ways to store state is parcelize, map saver, list saver. Okay. The simplest solution is to add parcelize annotation the object. Parcelize. All the other that are added to the bundle are saved automatically. If you want to save something that cannot be added in the bundle, there are several options. Is parcelize. We also use parcelize. I've made a video on it, or I wrote an article on it. What is parcelize? Simple solution in Java. But annotate object become parcelable and can be bundled. For example, the code that makes parcelable city that are saved in the state. Parcelize. If we have some reason parcelize not suitable, you can use a map saver to define its own role for convenience and object. So you can go through this article. Save device state. UI logic. verifies communication, saves state, and develop PI and this kind of thing. The Yamba save automatically values automatically saves in it can be saved in bundle for that you can check. Restore state of cake news partialize and map saver and this kind of thing you can use to ob- store object in recomposition. Remember save automatically saves in that can be saved in bundle for that because the custom saver object for information. Check out this as I have just shown. So in water account replace remember saveable. If we use the remember saveable, it will restore the screen orientation. On the app now instruction to configuration, you should see the counter is properly saved. This will restore the state, preserve the state. Activity recreation is just one of the use cases of activity recreation. Activity recreation is just one of the use cases. Remember, Sable will explore another use cases later while working with the list. Use members able to restore UI state after an activity is recreated. Use members able to restore the UI state. Use members able to restore the UI state after activity is restore the UI state after activity is recreated. Besides retaining state across recomposition, membership also retains state across activity recreation and system initiated process that. Okay. Yes, remember savable. Process that is also another concept. Similar to this, not similar, it's defined from the configuration changes. The system UI automatically deletes some apps data, so there's also process that. So use remember able to restore UI state after activity recreated besides retaining state across recomposition. Remember able also retains state across activity recreation system initiated process that. Okay, it also retains the state in process that also remember able. Okay, got a good idea. Consider whether to use remember save depending on the app state and UX need. So it's good to use the remember saveable. Now let's learn about what is state hosting is. State hosting is simple. State hosting is simple here. Let's show you. What is state hosting? When we extract state from a composable function, which is stateful before and after executing composable function in a stateless, composable function can be made stateless by extracting the state from them. This pattern is called state hosting. In the next, you'll see how to host or lift the state from composable to make it state. State hosting is a pattern moving state to its caller to make a component stateless. So that's the concept of state hosting. So let's go to Codelabs. So a composable that uses remember to store an object contains the internal state. A composable that uses remember to store an object contains the internal state, which makes a composable stateful. To use a composable that uses remember to store an object containing internal state, which makes a composable stateful. This is useful situation where a caller doesn't need to control the state and can use it without having to manage the state themselves. However, composable with internal state tend to be less reusable and harder to test. Composable that don't hold any state are called stateless composable. An easy way to create a stateless composable is state hosting. Easy way to create a stateless composable is by using state hosting. State hosting in compose is a pattern of moving state to composable caller to make composable stateless. The general pattern for state hosting that we compose choose to replace the state variable in with two parameters. The general pattern for state hosting in FA compose is to replace the current state with two parameters value t, the current value to display non-value state, and event that they request the value to change with the new value t. An event that requires the value to judge vulnerability. Where this value represents any state that could be modified. Where this value represents any state that could be modified. The pattern where the state goes down, the event goes up is unidirectional. The pattern where the state goes down, an event goes up. Where the state goes down, an event goes up is called unidirectional data flow. And state hosting, unidirectional data flow. The pattern where the state goes down, and event goes up is called unidirectional data flow. And state hosting is how we implement this architecture in Compose. You can learn more about this in the Compose architecture documentation. State that hosted this way has some important properties. The state that is hosted this way has some important of this property. Single source of truth. Yes. So state hosting is a very good architectural design pattern, and it is also called the unidirectional data flow. Okay. So the state that is hosted this way has some important property. Single source of truth. By moving state instead of duplicating it, we are ensuring that there is only one source of truth. This helps avoid bug. By moving state instead of duplicating it, we are ensuring there is only one source of truth. This helps avoid bugs. Shareable. Hosted state can be shared with a multiple composable. Hosted state can be shared with multiple composable. Inter intercept interceptable. Callers to the stateless composable can decide to ignore or modify event before changing the state. Callers to the stateless composable. Callers to the stateless composable can decide to ignore or modify event before changing the state. Decouple the state for the stateless composable function can be stored anywhere, for example, in a view model. The state for the stateless composable function state that is hosted this way can implement properties. Single source of truth. By moving the state instead of duplicating it, we are ensuring there is only one source of truth. This helps avoid bug. Hosted state can be shared with multiple composable. Yeah. Callers to the state composable can decide just to ignore modify the event before. Callers to this state composable decide to ignore or modify the event before changing the state. The state of the stateless the state of a stateless composable function can be stored anywhere. For example, in a view model. Yes. Try to implement this for the account so it can benefit from this above. So stateful versus stateless. When all the state can be extracted from a composable function is when all state can be extracted from a composable function, that resulting composable function is called stateless. A stateless composable is composable that doesn't own any state. This means doesn't hold or define modify a state. A stateful composable is a composable that owns a piece of state that can be changed over time. In real life, shipping 100% stateless composable can be difficult to achieve depending on the composable responsibilities, and you should design your composable in a way that will only use as little as state possible and allow the state to be hosted, which it makes sense by exposing it to the composable API. When it makes sense by exposing to its composable API. The effect of the water count composable by splitting it into two parts, stateful versus stateless. The role of stateless counter. The role of stateless counter is to display the count and to call function and increment count. Stateless counter is given an lambda function to it, passing a function to it, anonymous function. Event on event button on click stateless counter. stateless counter. The rule of the stateless counter is to display count and call the function when you increment the count. To do this, follow the pattern described above and pass the state counter as parameter to the composer function and lambda that is called when the state needs to be incremented. Stateless counter looks like this. The rule for the stateless counter is to display count and call the function when you increment the count, and call the function when you increment the count. Call a function when you increment the count. Pass the state count parameter to the compose function and lambda. Increment count plus plus. So the state has been extracted from this to that, and we passed a lambda to it on increment, and we call the on increment to count plus plus. Okay, and a simple modifier. So you hosted your count from a stateless counter to stateful counter. You can plug this into your app and update your screen with a stateful counter. Okay, key point is simple. When hosting a state, there is 3 rules that helps you figure it out where state should go. State should be hosted to at least lowest common pattern. State should be hosted at least the lowest common pattern for all composable that uses the state read. State should be hosted at least to the highest level it may be changed. State should be hosted to at least the highest level it may be changed. If two state changes in response to the same event, they should be hosted in the same level. If two state changes in response to the same event, they should be hosted in the response to the same event, they should be hosted in the same level. Okay, you can host state higher than this liquor, but if you don't host the state higher enough, it might be difficult to impossible to follow unidirectional data flow. Okay, as mentioned, state hosting has some benefit. We will explore some variant of this code explain in some depth. You don't need to copy the following snippet on your app. Use your stateless composable now can be reused. Your stateless composable can your stateless composable now can be reused. Take for instance the following example. Your stateless composable now can be reused to count glasses of water and of juice. You remember the water count and the juice count, but use the same stateless counter composer function to display the two defined independent state. So stateful counter bar water count by remember mutable state of 0, juice count by remember mutable state of 0, state counter water count. So we can reuse this to okay. The chilling composer can now reuse take an instance of the following example stateful counter. 2 many argument for one stateful counter. juice counter, water counter. So this can be used. So if the juice count is modified, then stateful. If juice count is modified, then stateful counter recomposition compose an anti-average function to the juice count and trigger recomposition of only those functions. Is a recomposition juice count, depth increment juice count, stateful composition, and so it does the stateless counter is the juice count, but stateless counter that is the water count is not recomposed. So your stateful compose function can be provided the same state to multiple composable functions. So it is reused. So in this case, if the account is updated by either stateless or another stateless method, everything is recomposed, which is expected. Which is expected. Because hosted state can be shared, be sure to pass only the state that is composable needed. Because hosted state can be shared, be sure to pass only the state that is composable needs to avoid unnecessary recomposition and increase reusability. Because hosted state can be shared, be sure to pass only the state that is recomposition needs to avoid unnecessary recomposition and to increase reusability. Hosted state can be shared, be sure to pass only the state that is recomposition needs. So it's more about state and state hosting. Check out the compose state documentation. Work with list. So next we'll add the second feature of your app, the list of wellness. So you can perform two action the same item on the list. Check item to mark the task as completed. Remove the task from the list if you are not interested in completing. Let me take a 5-minute break right now. We'll get back to this Codelab. You'll learn about the lazy list, lazy column. Then you'll learn about the observable state in view model. Let's take a break of 5 minutes. So let's work with the list. Okay. Next, add the second feature of the app, the list of wellness tasks. You can perform two actions with the same item on the list. Check list item to mark the task as completed. Remove the task from the list as you are not interested completing. First, modify the list item. You can reuse the wellness task item from the remember in composable section and update it with the container checkbox. Make sure you host the checked state on checked callback method. Make sure that you host the checked state and the unchecked change callback to make the function stateless. Make sure you host the check state and the unchecked change callback to make the function stateless. Okay, wellness task item. Compose of the section should look like this. Checked boolean unchecked. Unchecked change checked state. Okay. Checked. Icon button. Unchecked change. On close and unchecked. These are state hosting. Wellness task item. In the same file, add a stateful wellness task composable function that defines a state variable, check state, and pass it to the stateless method and of the same name. Don't worry about on close for now. You can pass it a empty lambda. In the same file, add a stateful wellness task item. Composition function defines the state variable, check state, and pass it to the stateless method in the same name. Don't worry about on close for now. We can pass the empty lambda function. Wellness task item. The edit wellness task item. Wellness task item. Double call করে দিয়েছে বুঝলাম না okay because this is name is same but parameter is different. Okay, method was loading. Okay, so wellness task item is calling this stateless and the wellness task this is a stateful, so it's calling from the stateful task item. uncheck state boolean new value. It will be boolean. If we don't specifically mention, we can just check the item is it. We can give this, okay, but it's good for visual understanding. Uncheck change, unchecked change, checkbox uncheck change, and this is checked and on close. Icon button on click. Uncheck change, checkbox uncheck change, and on close checked. Checked is checked state. Uncheck change is new value. Check state new value. Will implement this on close. Okay, wellness task item. Now create a file data. Create wellness task item to model task item that contains ID and label. ID and label. Wellness task. Wellness task ID and label. ID and label. ID for the which item is in which position. That's why ID. For the now note that in the lab you get data from data layer. Wellness app. Add a composite function that creates a list in a wellness task list. In wellness task list. In wellness task list, add a composable function that creates a list. Define the lazy column and items from the list method. You create a check out the list documentation if you need help. Wellness task list. अच्छा अब items list wellness task get wellness task. Okay, wellness task get wellness task, remember, right? Wellness task item task name dot label task name dot label. List of wellness task, remember, lazy column modify item item this list item item है list, उसको ना सिंगल आइटम को कन्वर्ट किया है, ठीक है, सिंगल आइटम टास्क डॉट लेवल पे पास कर दिया, ठीक है. सो वेलनेस टास्क पे देन अनचेक्ड इनचेक्ड इसके अंदर है. नाउ Add the wellness screen. Add this list to wellness screen user column to help particularly. Now add the list to wellness screen. Add the list to wellness screen. Note, add the wellness screen. Add the list to wellness screen is column. The column wellness task. Add 6. Add the list to wellness screen. Use the column to help particularly align the list and the counter you already have. Okay. You put a WC in the editor area of the studio. It opens a suggestion box. WC. It's not working. Here. Wellness screen counter. Stateful counter wellness screen. When the event gives a you should have been able to check tasks but not delete them. You'll implement that in the later. For the list to take item. For the list of task site itself, create a new file named wellness task list and add the method that generates some fake data. Wellness task list. Get wellness task list I list of such 30 I wellness task ID equal to I task I. Get wellness task 30 and I. Add the list of wellness screen user column to help particularly align the list with the counter you already have. Run the app now and give it a try. You should now be able to check tasks but not delete them. You will implement that in the later section. Restore item state in lazy list. Let's run the application and let's see how the application currently looks like. So application is looking great here. I can check and uncheck the checkbox, but item is not deleted. Take a close look now at something in the wellness task item composable. Check state belongs checked state belongs to each wellness task item composable independently. Take a close look at now at some of the thing in the wellness task. Check state belongs to each wellness task item composable independently, like a private variable. When check state changes, only that instance of wellness task get recomposed, not all wellness task instance of not all wellness task instance of the lazy column. That's a very important concept because of using the state hosting. Mm, when the check state, only the instant of this particular item is changed, not all. Check state new value, check state equal to new value. Okay, that's part of state hosting. When the check state changes, only the instance of this wellness task is get recomposed, not all the wellness task item instance of lazy column. Try out it Try it out by following this step. Check any element at the top of the list. Check any element at the top of the list. For example, element 1 and 2. Scroll to the bottom of the list so that they are off the screen. So check any element at the top of the list. For example, 1 and 2. Task 0, 1, 2. Scroll the bottom of the list so that they are off the screen. Scroll back to the top of the item you checked before. Notice that they are unchecked. There is an issue. As you saw in the previous section, that when an item leaves the composition state that was remembered is forgotten. For the item lazy column, item leaves the composition entirely when you scroll past them and they are no longer visible. How to fix it? Once again, use remember savable. Your state will be survive the activity or process the equation using the save instance state mechanism. Thanks to the remember savable works together with the lazy list, your items are being able to will also survive leaving the composition. Just place remember with remember savable in the stateful wellness task item. Remember savable. So common pattern in compose. Check and remember say multiple set of false. Common pattern in compose. Notice the implementation of lazy column. Lazy of lazy column. This composable function remember lazy state case. Notice the implementation of lazy column. Lazy state. Remember lazy state. Okay. So in the implementation of lazy column, here you can see the state is being remembered. Remember lazy list state. Remember saveable. So the composable function remember lazy list state case an initial state where the list using remember saveable. When the activity is recreated, the scroll of the state is maintained. When the activity is recreated, the scroll state is maintained without you having to code anything. So the composable function remember lazy list state case initial state for the list using remember variable. When the activity is recreated, the scroll state is maintained. When the activity is recreated, the scroll state is maintained without you having to code anything. So when the activity is recreated, the scroll state is maintained. When the activity is recreated, the scroll state is maintained without you having to code anything. Many apps need to react to listen to the scroll position, item layout changes, and the other event related to list. Lazy component like lazy column or lazy row. Suppose these use cases to hosting the lazy state, and you can learn more about this pattern in documentation for the state. Having a state parameter with a default value provided. Having a state parameter default value provided by public remember x function is a common pattern in a built-in composite function. Another example can be found in the bottom state scaffold, which holds state using remember bottom state scaffold state. Okay. So that's it about working with list. So you might be saying, why this ID variable? ID variable is position of the item. That's why. Let me show you. ID. If we remove this, remove it and run this. Let's see what happens. Task. That is showing error 2. This I int level list of 30 and ID. Everything is an ID. I equal to wellness I task I int ID. If we don't give ID, then we don't reuse this looping kind of thing. The list of Simple task 2020. Okay, so that's why I've given the ID. Observable mutable state. Now let's learn about the observable mutable state. Next, to add the behavior of removing tasks from our list, first step is to make your list a mutable list. First, to make your list a mutable list. This has to be mutable list. Using a mutable object for this, such as array list or mutable list of won't work. This type of would not notify composer that the item of the list have changed and scheduled the recomposition. You need an defined API. You need to create an instance of mutable list that is observable by compose. This structure lets you compose tracks changes to recompose the UI when items are added or removed from the list. Start by defining our observable mutable list. This extension function to mutable list is a way to create an observable mutable list from initial mutable or immutable collection such as list. Alternatively, you could also use the factory method mutable state list to create an observable mutable list and then add the element for your initial state. The mutable state of function returns an object of type mutable state. The mutable state of function returns an object of type mutable state. The mutable state of function returns an object of type mutable state. The mutable state list of and two mutable state list function returns an object of type uh, snapshot state list insertion etc. Observable mutable state. Start by defining our. So let's see. Now to add a behavior removing the task from our list, the first step is to make your list a mutable list. Using a mutable object for this type, array list or mutable list would not work. This type won't notify compositor item on the list have changed or scheduled for the composition. You need defined API. You need to create an instance of mutable list that is observable by compose. You need to create an instance of mutable list that is observable by compose. This structure lets compose track changes. So this structure lets Compose track changes to the compose UI when items are added or removed from the list. Start by defining our observable mutable list. Start by defining our observable mutable list. Start by defining our observable mutable list. The extension function. Start by defining our observable mutable list. The extension function to mutable state or list is a way to create an observable mutable list from the initial mutable or immutable collection such as list. Alternatively, you could also use the factory method mutable state list to create an observable mutable list and then add some element to the initial state. Mutable state of function returns an object of type mutable state. The mutable state list and to mutable state list function returns an object of type snapshot list. In this section, in terms of observable mutable list, refer to this class. To mutable state of if I move the get method, move get method to the file to this file. To be able to use it, create a list by calling get task. Wellness task. Open the wellness skin file. Move the get method to this file. This dot remove task. Okay, this dot remove task on close. Wellness task item label on close item. Wellness. Stateful counter. list. Remember, get wellness task to mutable list of wellness task list. Is list is list and close loose task, close remove item task, wellness task item. Okay, wellness task item, and there is a on close, on close. Wellness task item. Go to the function is complete. Now delete an item from the list over. If you click on the X delete in each row, the event goes all the way up to the list that owns its state. Removing the item from the list and closing the compose or recompose screen. State app, wellness task, on close task, on close task, on close task. Update the UI, event, state. If you try remember variable to store the list in wellness screen, you will get the runtime exception. If you try to use remember variable to store the wellness screen, if you try to use remember variable to store the wellness screen, cannot be saved using the can save state. Just the default implementation only supports a type which can be stored inside the bundle. You consider implementation custom saver for this and state pass it to remember save. If you try to use the remember save, the functionality is complete on the deleting item from the list works. Wellness task item list of wellness task name string on close task name. The error tells you that you need to prove the custom saver. However, you should not be using member variable to store large amount of data. Complete or such data request length is serialized and deserialized. Similarly, apply when the workflow activities on same instance. If you want to find more information on the saver state documentation, if you want to do it, you need alternative store mechanism. You can learn more about the kind of option previously of for preserving state in the documentation. I will look about the model to the holder of state. Let's see. Something is missing from this application. That's where it is. Delete those previous code and on close. Well, remember, get understand the two mutable list. Get wellness task dot two mutable state list. State list. Get wellness task list on close task. On close task list dot remove list dot remove. And in the wellness task, in the wellness task, modify list dot list wellness on close task list of wellness task you need on close task wellness task you need modify item task with id task equal to this on the task with id list is item equal to list key equal to task lazy column items equal to list key task dot id task wellness task item task dot level on close task wellness item on close task name string check state by remember savable mutable state of false task state as once item in the middle of the state on close is on close. I think this list has to be mutable, I guess so. Let's see. something is really wrong there. So let's uh, go to the view model part. Okay, the screen or the UI state indicate what should display on the screen. For example, the list of tasks. The state is usually connected with other layer of the hierarchy because it contains application data. The screen or UI state indicates what should display on the screen. For example, the list of tasks. The state is usually connected with other layer of the hierarchy because it contains application data. While the while the UI state describes what to show on the screen, the logic of the app describes how the app behaves and should react to the state changes. There are two types of logic: the UI behavior or UI logic and the business logic. The UI logic relates how to display state changes on the screen. For example, the navigation logic or showing snack bar. The business logic is what to do in the state changes. The screen or the UI state indicates what should be displayed on the screen. For example, list of tasks. The screen or the UI state indicates what should display on the screen. For example, list of tasks. This state is usually connected with other layer. The state in view model. The screen or UI indicates what should display on the screen. For example, list of tasks connected with the other layer because it contains application. While the UI state describes what to show on the screen, the logic of the app describes how the app behaves and should react to state changes. There are two types of logic: the UI behavior, UI logic, and the business logic. The UI behavior or UI logic and the business logic. The UI relates to how to display state. The UI logic relates to how to display the state changes on the screen. For example, navigation logic or showing snack bar. The business logic is what to do with the state changes. For example, making a payment or storing user preferences. This logic usually plays in the business or data layer, it never in the UI layer. B model provides UI. B model provides the UI state. B model provides the UI state and access to the business logic located other layer in the app. Additionally, B models survive configuration changes so they no longer lifetime. So they have no longer lifetime than the composition. You can follow the life cycle of the host of the composed content that is activity. You can follow the life cycle of the host of the composed content that is activity segment of the destination navigation graph if you're using compose navigation. Textual value. View model are not part of composition. Therefore, you should not be hosting state created composer, for example, remembered below because this could cause memory leak. For example, should not hold state created in the composable, for example, remembered below because this could cause memory leaks. So migrate to list and remove method. While the previous step showed how to manage your state directly in the composer function, it's good practice to keep an UI logic and business logic separate from the UI state and migrate to a computer model. Let's migrate to UI state. The list to you. View model also started extracting business logic into it. View model also start extracting business logic into it. Create a wellness view model, create a view model class. Move your data source, get wellness class to the view model. Define an internal task variable using the mutable state list of where you did before and expose the task as a list so that it's not modified from outside view model. Implement a simple remove function so it deletes the list built-in remove function. Create class on this view model, private for task, get on this mutable list and the getter, public getter, build task list, wellness, remove item task, so remove private fund, get wellness task, so list I dot this we can access this view model from any composer by calling view model function. To use this function, open the app build get ESI the following library to sync the dependency in Android Studio. Use the version 2.6.2 when working with Android Studio. Giraffe else check the latest version library have. So just a second, let's take a pause now. 5 minutes. I will then learn about this concept of view models. Very important in Android. Before going to the Fireball, currently I'm back now after some rest. Let's ask the UI why the remove button is not working. Why the close button is not working. Because you're passing lambda that returns a function reference not calling it. What currently happening on close on click return a function it should be, but we are not invoking it. Okay, that's the issue. Let's see on close. Okay, icon button, not icon button, it should be on close. Let's run the application. I was also thinking what went wrong, man. Yeah, now the application is working as expected. So let's do let's now go to the view model. Let's now go to view model. The screen or the UI state indicates what should display on the screen. For example, the list of tasks. There, this state is usually connected with the other layer of the hierarchy because it contains application data. While the UI state describes what to show on the screen, while the UI state describes what to show on the screen, the logic of the app describes how the app behave and should react to state changes. There are two types of logic, the UI behavior and the UI logic and the business logic. The UI logic and the business logic. The UI logic relates to how to display state changes to the screen, for example, navigation logic on showing snack. But the business logic is what to do with state changes, for example, making a payment or storing user preferences. The logic is usually placed in the business or data layer, never in the UI state. View model provides a state that access to the business logic lo located other layer in the application. Additionally, B models survive configuration changes, so they have a longer lifetime than the composition. So they can follow the life cycle. They can follow the life cycle of the host compose content, that is activities. They can follow the life cycle of the host to the compose content, that is activities, fragment, and destination navigation. To learn about the architecture and evaluate, check out the UI documentation. B model are not part of the compose, therefore you should not hold state created in composable state. You should not hold state created in composable, for example, the membered value, because it could cause memory leak. So migrate the list and remove the method. While the previous step showed how to manage the state directly in the composable function, it's good practice to keep the UI logic and business logic separate from the UI state. Keep the UI logic and business logic separate from the UI state and migrate to the view model. Let's migrate the UI state, the list. Let's migrate to the UI state, the list. Let's migrate the UI state, the list to your view model. Also start extracting business logic to it. So let's migrate the UI state, the list. Let's migrate the UI state to the list to your view model and also start extracting business logic into it. Create a file wellness view model and add to your view model class. Create a file wellness view model to add to your view model class. wellness view model. Morbid data source get view model define data source in the database table. Wellness view model, class wellness view model. I need to remove those. To mutable state and the next life cycle view model. So we can access the view model from any composable calling view model function. To use this function, open the evidence sync to the dependency. Let's see. Use the version 2.6.2. 2.6.2. When working with Android Studio Giraffe, else check the latest version of the library here. So open the wellness screen. Open the wellness screen. Instantiate the wellness view model. View model by calling view model as parameter of the screen composition, so it can be replaced with the when testing with composable and hosted if link required. Provide the wellness task list with the task list and remove the function on close task lambda. View model wellness view model. So open the wellness screen, instantiate the open the wellness screen, instantiate the wellness view model. Open the wellness screen, instantiate the wellness view model by calling the so task is get task list, okay, and remove task. That's the business logic, okay. Instantiate the wellness view model by calling wellness screen is view model, wellness screen to view model. So count modifier on close task, mutable state, list of remember state counter. So this has to be deleted. Remember is no longer needed. So wellness task list is the task, and on close task is on close task is task wellness b model dot remove tasks. Okay, so b model returns an existing b model task is that, and remove and task. Okay, remove भी हो गया और ये भी हो गया, remove भी हो गया और task भी हो गया, ठीक है ना भाई. So B model returns an existing B model. B model returns an existing B model or creates a new one in the given scope. The B model instance is retained as long as the scope is alive. For example, if the composable is used for activity B model, so if the composable is used in an activity, B model returns the same instance until the activity is finished or the process is killed, and that's it. So B model returns an existing B model. B model returns an existing B model or creates a new one in the given scope. The B model instance is retained as long as the scope is alive. B model returns an existing wellness B model, how it is called. There it is called. B model returns an existing B model, creates a new one in the given scope. The B model instance is retained as long as the scope is alive. For example, if the composable is used to activity B model, if the compose is used in an activity, B model returns the same instance until the activity is finished or the process is killed, and that's it. We have integrated B model with the part of the state and business logic to your screen. Since the state is kept outside of the composition and stored in the B model, then that's it. You have integrated the B model with the part of the state and business logic with your integrated B model with the part of the state and business logic with your screen. Guitar resource. Just remove, get wellness task or two mutable task and this. Okay, and this is integrated B model part of the state business logic. Since the state is kept outside the composition, so B model mutation distinct away configuration changes. That's it. You have integrated the B model with a part of the state and business logic to your screen. Since the state is kept outside of the composition and since the state is kept outside of the composition, since the state is kept outside the composition and stored in the B model, since the state is kept outside of the composition. Outside of the composition. The state survive configuration changes. Wellness B model dot remove B model dot task on close B model dot remove. Wellness state. As that said, you have integrated B model part of the state of business logic. Since the state is kept outside the composition stored in a B model, mutation to the state survive configuration changes. B model on automatically passes the state. Data is coming from here, don't care. That's why. If integrated, the B model is the part of the state and business logic of the skin. Since the state is kept outside the composition and stored in B model, mutation to the less server configuration changes. B model won't automatically passes the state of the app scenario. B model won't automatically passes the state of the app in any scenario. For example, for system initiated process that since the state is kept outside the composition and stored in B model, mutation to the state mutation to the list server configuration changes. B model won't automatically passes the state of the app scenario. B model won't automatically passes the state of the app scenario. B model won't automatically passes the state of the app scenario. For example, for system initiated process that for detailed information about persisting API state, check the documentation. B models are recommended to be used at a screen level composable. B model are recommended to be used at screen level composable, that is close to a root composable called closed close to a root composable called from an activity fragment or destination of navigation graph. V model are recommended to be screen level composable, that is close to a root composable called from an activity fragment destination or navigation graph. B model should never be passed down to other composable. Instead, you should pass it only to the data they need to function that perform the required logic as parameter. Check out the B model stakeholder section uh, and compose another basic documentation to learn more. Migration checklist. The last refactor is to migrate the check state check state and the logic to the B model. This way, the code is simpler and more testable. So the state managed by the B model. Migrate the check state. Okay. The last refactor is to migrate the The last refactor is to migrate the check state logic to B model. So this way the code is simpler and more testable with all the state managed by the B model. All the state. Let's see. Management of B model. First, modify the wellness task model class so that it's able to store the checked state and set the false default value. Wellness task and B model. Get wellness task. The wellness task model class. I In the B model implement a method change task check that receives a task to modify the new state for the check. Wellness B model. Change task checked item. Wellness checked boolean. Task will find it to the name later. Task will check. What does it mean? What does it mean? So in the B model, implement a method change task change that receives a task to modify a new value for the checked state. Okay, this is the old one, this is new one. Replace state for with this, and then using the let function, the task to checked is check change task checked. Okay, in wellness screen provide the behavior. So in wellness screen provide the behavior for the list on check task by calling the B model change task check method. This function should now look like this in the wellness screen. In the wellness screen provide the behavior for the list on checked task by calling the B model change task check method. This function should now look like this on close task. Wellness task list here. On close task. list list the task. On task to check wellness task list. One is a bad practice to pass down vmod instance to other composable. You should pass only the data they need to function. That perform the required logic as parameters with the integration from the existing application. In the wellness task, add the unchecked lambda function the parameter so you can pass down to the wellness task item. One unchecked task. Wellness task item unchecked. Wellness task item. Wellness task item. Lazy column. Wellness this item task. Level on close. On close. So clean up a wellness task item. We no longer need to a stateful method check. The checkbox state will be hosted is the file is only decomposable. Wellness task item. Clean up the wellness task item. Do not need a stateful method as a checkbox state will be now be hosted in the list level. The file is only the composable method. Okay, wellness task item. Let's do wellness task item. Wellness this will delete by unchecked change. Check to the boolean. Unchecked change checkbox. Checkbox lazy column dot item. Wellness task list. Wellness task item. Not need a stateful method as a checkbox state will be hosted in the list level if and only as the composable function, right? So stateful is again now the app try to check the notice that the checking and that doesn't quite work yet. This is because what compose takes a mutable list are changes related to. Let's run the application now. So this is because what compose is tracking for the mutable list has changes related to adding and removing element. This is why deleting works. This is why deleting works, but it's unaware of changes in a row because it's unaware of changes in a raw item value check state in our case unless you tell it to track them too. So this is because what compose is taking for the mutable list are changes related to adding and removing element. This is why deleting works, but it is unaware of changes in a row item value check state in our case, and this will tell to track them too. Change the data class as well class. So the check state becomes mutable state. Change the our data class when the state. So the checks will be mutable change to boolean, which cause compose with track the item. Just copy the item you are about to remove the item from the list and re-add the mutable item in the list, which causes the compose with track list changes. Check. Let's see. Wellness task. Mutable state. Mutable state. Now let's run the application. Let's see. As As you saw before, you can use delegate property which results in simpler uses to the variable checked for this case. Argument mismatch. As you saw before, you can use delegate property which results in simpler uses to the variable checked for this case. Change wellness task to be class instead of change wellness task to be class instead of the data class. Make wellness task receives initial checked variable with default use of value in the construction that we can initialize the checked variable with the factory method mutable state of taking initial checked as a default value. Wellness task দুইটা আমি উদাই দিম ভাই the variable factory method mutable state the solution was no changes survives decomposition configuration changes. Testing now that the business logic is refactored in the B model instead of coupled inside the composable the function unit. Testing is much simpler. Now you can use instrumented test to verify. Okay, now the app is working fine. I've just tested on my physical device. You can use instrumented test to verify the correct behavior of a composable state working. So let's see how many state we have just delegated or migrated to view model. Uh, Change state task checked this state, remove state, and then get all the tasks. Add one is still in the main activity. Add is still in the main activity. Let's see. Wellness skin. There is no state. There is a count state. This is the counter of remember variable is for classes and all kind of thing. So this is there, but other than that, stateful counter. Other than that, this wellness task, there is no state. Wellness task item also there is no state, so state has been removed and added to state has been removed and it's migrated to view model. So view model doesn't need it, remember it's already survived the decomposition, configuration changes, etc. Let's see. So I think that's it for this video today. We have learned a lot today. Let me see if I can write a blog article on this view model because view model is very important. Okay, let's go to the congratulation part. What it says: good job, you successfully completed the Codelab and learned about all the basics API to work with the state of Jetpack Compose. You learn how to think about state and event and extract stateless compose, how to compose using state uplist. So you learn how to think and state and events to extract the stateless composable in compose and how to compose user state to update drives changes UI. Mm, simple F jet news is mostly the best practice explained in this Codelab. You can also see the simple labs which is jet news. This simple is skin, list of article details, page and subsequent test navigation. The navigation from the list articles interest the skin navigation tab. Okay, this also shows what is jet news demonstrates the best practice explained in this Codelab. Okay, view model and state hosting, all kind of thing. So you can look more on thinking and compose state, introduction data flow, jetpack compose, etc. Restoring state, view model of our view, compose of the library, the files, remember stable state, mutable state, snapshot, state list, etc. So it's a so this code level is very important. This state in jetpack compose. So that's it for this video today. I'll see you in some other video. I think I will need to write an article on this. See you. Bye bye.